What is cavity magnetron? Today I will discuss about the cavity magnetron. Cavity magnetron is called cavity magnetron. Why? Because anode is made into resonant cavity. That's why we call cavity magnetron it. Its formation and construction, how it is and formed, we will know that. Here is the metallic. This is the cross-sectional part of the figure. Here is the cathode, which is a metallic cylinder, and these are the cavities connected with in this manner. These are tightly bound in this way, and these are called anode cavity. And the space between the anode cavity and the cathode is called interaction space, and the output is connected here with the multi-layered metals. That's the resonant frequency output, and these are coaxial line up to give us output. And a permanent magnet is also used to produce a strong magnetic field where the action of both of these make the device to work. Here the magnetic field is perpendicular to the electric field. Here electric field is electric field present is radially, that means in this way cross-sectionally, whereas the magnetic field is axially, that means in this way, in this inside way. Okay, now type of the cavity magnetron. Cavity magnetron are three types, and this is negative resonant type, which produce low frequency radio frequency, low frequency. Okay, and cyclone frequency magnetron is produce high frequency, whereas traveling wave and cavity type, this is used in radar. Let's understand a little bit about working of it. This cavity magnetron has 8 cavities tightly covered to each other, and N cavity magnetron has N mode of operations. The total phase shift of this resonator should be 2n pi. Here n is an integer, and maybe 1, 2, 3, 4 and so on. If the phase change phi is denoted by phi v, that's equal of 2 pi n upon n, where n is the even number. We can put it, if n, small n, is equal of n upon 2, that means then the phase change in the output frequency that we are considering here, radio frequency, and that have the phase change as phi v 2 pi n upon n. If n equals to n upon 2, phi v equals to of pi, that means phase change, the change in the phase of the outcoming frequency will be phi. If n equals to 0, then phi v equals to of 0. Now understand why cavity magnetron is used. What is the work of the cavity magnetron in electronics? Magnetrons are cross-filled tubes in which the electric and magnetic fields cross each other in this way perpendicularly. In TWT, traveling wave tube, that means traveling wave tubes, it was observed that when electron made to interact with radio frequency for a longer time than in cavity magnetron resulted in higher frequency. That means to create higher frequency we use cavity magnetron.